Hello everyone, welcome to today's maths lesson where we're going to be exploring fractions greater than 1. Okay, so hopefully you've had a chance to recap over fractions on Friday and then yesterday you'd have had your equivalent fraction lesson. Okay, get those brains warmed up with a little arithmetic starter for me. If you want to pause me, then I'll reveal the answers. Right, okay, so multiples of 9 are just any number in the 9 times table. We've listed some here, but obviously even if you've got a bigger number, as long as it's in the 9 times table, that counts. Number 2, you multiply the numerator by the whole number, 4 times 6. Denominator stays the same, so it'd be 24/6. Don't worry if you're not sure on that. We're going to revisit that later this term. Number 3, you've divided by 1,000, which would be 1.982. We're shaking it to the right. Number 4 is 2 cubed, 2 times 2 times 2, which is 8. And then number 5, we've got an addition there. So you'd have probably done that. Column method is what I'd have done for that. Okay, so let's get straight into it. Exploring fractions greater than 1. Let's start with, what are fractions again? Fractions are equal parts of a whole. That's how I remember it. Okay, so when we've got a whole and we've cut it into equal parts. All right. A fraction greater than 1 is just when you've got something that's worth more than a whole. And we're going to explore what that looks like today. Okay, so if we start with, it's quite small here, so I'm going to kind of do it as I go along here as well. So we've got the fraction here. We've got 5 at the top, 4 at the bottom, which we know is 5/4. Okay, now, is there anything different you notice about this compared to other fractions you've looked at? Well, hopefully you've noticed that the number on the top, the numerator, is bigger than the bottom number, the denominator, okay, which is quite unusual in terms of what we've looked at before, because our denominator tells us how many equal parts something's split into. So for 4, we've got a whole, over here my bars, and they're split into 4 parts, yeah? And my numerator is just how many of those parts I've got. So normally it's how many parts I've got, like shaded in this example for a picture. So if I shade that in, hopefully you'll be able to see straight away why I've had to draw 2 bars, because if I shade 5 parts in, I've got 1, 2, 3, 4, 5 equal parts highlighted, not the neatest highlighting. And you can see that's more than 1 bar, isn't it? And 1 bar is a whole. I've got more than 1 whole. So let's have a look. If we fill this in, so there are 5/4 altogether. When I say altogether, I mean that I've got 5/4 altogether that I've got. And if we think about 5/4, what that's worth, well, how many whole bars can you see I've shaded in? Hopefully you can see, look, I've got this 1 bar where the whole bar is shaded in. So I've got 1 whole, and then I've got 1 little quarter left on its own. Can you guys see that? Yeah, I'm hoping you can. So there are 5/4 altogether that I've got. 5/4 is the same as 1 whole and 1/4 here. Okay, now have a go. See if you can pause me and have a go at these bottom 2 yourself. Okay, if you're not sure, you can just unpause me and I'm going to show you them. All right, so if we look here, my denominator's been done for me. It's 3. The reason it's 3 is because each bar, my whole, is split into 3 equal parts, yeah? My numerator is how many I've got. Let's see how many I've got altogether. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8/3 altogether, and I can write this here. I can't, for some reason, I can't type over these, so I'm hoping you don't mind. I'm going to do it this way, okay? So if we look at splitting that into the wholes and the parts, I can see here, and I'm hoping you can too, that there are 2 whole bars shaded, okay? So we've put those over here, and 2 whole bars, if we count them up, 1, 2, 3, 4, 5, 6. That's the same as 6/3. All right. So 6/3 or 2 whole bars there. Yeah. And then the one that isn't a whole, I've put over here, and I can see that out of the 3 parts, I've got 2 shaded in. All right. So that's the same as saying 8/3 is the same as 2 wholes and 2/3 on their own. Okay, if you didn't pause me before, why don't you pause me now and see if you can have a go at this second one? Right, nice and simple. So we count up. There are 7 quarters altogether that I've got shaded in. There are 7 quarters. And if I move, I've got 1 whole bar that I've put on its own over here. So 1 whole or 4 quarters. And you'll notice the numerator and the denominator are the same there. And then I've got the bar that isn't a whole on its own over here, which is 3 quarters. So 7 quarters is the same as 1 whole bar and 1 bar with 3 quarters shaded in. So 1 whole and 3 quarters. I just want to do a quick pep talk in the middle of this. I know this is loads to take in. We are going to spend lots of time going through this one step at a time. So don't worry. All we're focusing on today is thinking about fractions greater than 1. All right. Stick with me, guys. You're doing amazingly. All right. Pep talk over. So if we look just thinking about numbers then. So 10 thirds. Well, if I wanted to split that into 2 parts, I've got here, I've done 9 thirds. Okay. So if I've got 10 thirds altogether, if I put 9 thirds over here, then I'm going to have 1/3 left to put over here. Do you agree? Because if I do 9 and 1/3, that's going to equal my 10 thirds, my whole. Okay. So let's have a think. 9 thirds. How many whole bars would I make out of 9 thirds? I guess you could ask yourself, how many groups of 3 can I make out of 9? So if I have a real quick look, I think this video is probably going to be in 2 parts, guys, because there's quite a lot I need to go through with you. Okay, so bear with me. So let's just prove what I'm thinking. So 9 thirds. Well, if I do roughly, so that's split into 3 equal parts. So's that, and so's that. And if we look at colouring them in, I think you guys can see straight away. 1, 2, 3, 4, 5, 6, 7, 8, 9. That equals 3 wholes exactly, doesn't it? So 9 thirds there equals 3 wholes. I've got my 1 left. So 10 thirds is the same as saying 3 wholes and 1/3 there. Okay, so have a look over here and see if you can fill in the sentences. So if I fill in this one so that you can see what we've done there, see if you can have a go at filling in the gaps using my example to help. Right, if we look here, so this is going to be the total number of thirds I've got. So 6 thirds add 2. If I do 6 add 2, that's going to equal 8 thirds. 8 thirds would equal, I've got my 2 thirds already. So then I need to work out how many wholes 6 thirds would be. How many groups of 3 can I make out of 6? It's 2. So 8 thirds is the same as 2 and 2 thirds. Okay. And again, this one, if I've got 16 add 3 eighths, that's going to be 19 eighths in total. And then if I think about, so how many groups of 8, or how many whole bars of 8 can I make out of 16? That will be 2. And then I'll have the 3 eighths spare. Now I'm going to show you a quicker way of working this out. Okay, so don't worry if that all looked quite complicated to you. Remember, a bit like with our multiplication and division, there's lots of different methods for this. And sometimes seeing it works really well for people. Sometimes not so much. Okay. So here we go. We've got a word problem here, and we're going to use what we've just looked at to help us explore it. So 3 friends share some pizzas. Each pizza is cut into 8 equal slices. Altogether, they eat 25 slices. How many whole pizzas do they eat? So a bit like we were doing on this slide, we're looking to see how many wholes we make out of the fraction. Okay. And a question that's going to help us is how many make a whole. So if we look at the question, I'm just going to highlight what I think is the important information. So I've got 3 friends sharing some pizzas. Pizza's always important information. Each pizza is cut into 8 equal slices. Altogether, they eat 25 slices. How many whole pizzas do they eat? Okay, so I'm going to start by working out what fraction is being spoken about here. Now, the fact that each pizza is cut into 8 equal slices gives us our denominator, because that is literally what a denominator is, what parts it's cut into. And then the fact that they ate 25 slices gives us our numerator. That's how many parts they have, okay? So the question is, well, how many eighths make a whole? We're dealing with eighths here. So how many eighths make a whole here? How can we use that question to help us? I've got some trusty pizzas here to help us answer it, okay? So hopefully, I would always recommend, if you can't work out a question, draw yourself something that's going to help you explore it. So I've got lots of yummy pizzas. They're all cut into 8 parts here. And what I want to know is, if I've got 25 eighths, or they've eaten 25 eighths, how many whole pizzas is that? Well, firstly, can you tell me how many eighths make a whole? If we look at this one whole pizza, how many eighths are there? I can see that one whole pizza is the same as 8 eighths. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if one whole pizza is 8 eighths and I've got 25 eighths, how many wholes would that be? Well, we can use our 8 times tables to help here, because if I've got 1 is 8, that means 2 pizzas must be 16. Yeah, because 2 lots of 8 is 16. 3 lots of pizzas is 24 eighths, because 3 times 8 is 24. So I've got 3 whole pizzas there, and then that would be 24 eighths, but they had 25, so they would need 1 extra slice from somewhere else. Okay, so 1 extra slice here. So they've got 3 whole pizzas and 1/8 here that they've eaten. The question was just how many whole pizzas do they eat? So they ate 3 whole pizzas. Okay, that's a pizza each, those crazy cats. And then they've got the 1/8 there as well. Okay, so how many eighths make a whole? How many wholes are there in 25 eighths? That's what we'd be thinking about. Okay, so final part of this video is an extra challenge. If you would rather just get straight on to part 2 of the video, which is going to have one more worked example and then your activity sheet for today, you're very welcome to. Okay, totally up to you. But yeah, if you want an extra challenge, you've got a little reasoning question here where Rosie has said that 16 quarters is greater than 8 halves because 16 is greater than 8. Do you agree? Can you explain why? You can have a go. I've done some circles here to show that you could have a go at proving it using pictures, the way we did with like the pizzas. And then I will reveal the answers to you in just a minute. Okay, so hopefully you found that actually Rosie was wrong. Both fractions are equivalent to 4. Links to your equivalent fractions work there. Yeah, you might have drawn out and found that 16 quarters, you would have done 4 wholes split into 4. 16 of them is the same as 4. Same with the 8 halves. Okay, so yeah, if you're ready, move on to the second maths video. You're going to have one more worked example from me, and then we're going to get straight into the activity sheet you've got for today. All right, see you then. Bye bye.